Welcome to my YouTube channel. Dhanesh here. This is a video on electrostatics. See, in electrostatics, we covered many IIT JEE questions and its solutions for JEE mains and advanced, and theory. Also, we covered many videos we covered related to the theory part. We covered electric field, Coulomb's law, intensity of electric field, all these aspects we covered. So in this video, I am going to discuss about two aspects. One is what is electric lines of force and what is an electric dipole. Two aspects I am going to cover in this video. One is electric. The first thing I'm going to discuss is electric lines of force. What is electric lines of force? Second thing is electric dipole. So two aspects I am going to cover now: electric lines of force and electric dipole. Electric lines of force. Before getting into electric lines of force, in the last video I discussed about electric field. Even I discussed about contact and non-contact forces. And contact force, all mechanical forces are contact force, and non-contact force means gravitational force, electrostatic force, magnetic force. All these are all non-contact forces. In the case of non-contact force, we introduce the concept of a field we introduce. So what is an electric field? Electric field is the region around a charge where electric force of attraction or repulsion is experienced. After that, we defined intensity of electric field. Intensity of electric field at a point is defined as the force experienced by a unit positive test charge placed at that point. Two important formula I told you, and its derivation also I discussed with you. So for electric field, intensity of electric field, one important formula you need to understand: E is equal to, the first formula is F by Q. Second one, due to a point charge, this one we derived at that time, 1 by 4 pi epsilon 0 into Q by R square. This is the second formula. So these two formulas are important. So electric field, I told you, as I told, it is the region around a charge where electric force of attraction or repulsion is experienced. See, electric field is real, but we cannot see it. See, electric field is real, but we cannot see it. To visualize the electric field, we introduce the concept of electric lines of force. To visualize this electric field, we introduce the concept of electric lines of force. So the electric lines of force are imaginary concepts, but the field they represent is real. See, what is an electric lines of force? Electric lines of force are imaginary lines drawn in such a way that the tangent to it at any point gives the direction of electric field. This is really important. The tangent of electric lines of force gives the direction of electric field vector. This is a really important point you need to understand. See, the tangent of electric field always gives the tangent of electric field, the tangent of electric lines of force, electric lines of force always gives the electric field. That is really important. Tangent of lines of force, tangent of lines of force gives electric field. This is the concept. So what is an electric lines of force? Electric lines of force are imaginary lines drawn in such a way that the tangent to it at any point gives the direction of electric field. Electric lines of force are imaginary concepts, but the field they represent are real. And next point what I want to discuss is the characteristics of electric lines of force. See, what are all the characteristics of electric lines of force? I can tell you the first characteristics. So next is the characteristics of electric lines of force. The first characteristic says electric lines of force originate from the positive charge, starts from positive, starts from positive, ends on negative, ends on negative. This is the first characteristics of electric lines of force. Electric lines of force starts from the positive charge and ends on the negative charge. And if the intensity of electric field is higher, the electric lines of force are closely spaced, and if the intensity of electric field is smaller, the lines of force are widely separated. That is the second characteristics. So electric lines of force starts from the positive charge and ends on the negative charge. The second characteristics is if the intensity of electric field is higher, the electric lines of force are closely spaced, and if it is smaller, they are widely separated. The third characteristics, no two lines of force intersect. Two lines of force will never intersect. No two lines of force intersect. No two lines intersect. They won't intersect, because even they can ask a question like that, why electric lines of force never intersect? The reason is, if they intersect at that point, at the point of intersection, two tangents can be, for example, if you consider this is the point of intersection, at this point you can draw two tangents for the electric lines of force. That means at this point the electric field has two directions. Actually, electric field is a vector quantity and it is impossible. That's why they won't intersect. So the characteristics is electric lines of force will never intersect. If they are asking why electric lines of force never intersect, the answer is if they intersect at that point, at the point of intersection, two tangents can be drawn. That means the intensity of electric field at that point has two directions, but intensity of electric field is a vector, so it can have only one direction, so lines of force never intersect. So the first characteristics, they start from the positive charge, ends on the negative charge. If the intensity of electric field is higher, the electric lines of force are closely spaced. If it is smaller, they are widely separated. No two lines of force intersect. The reason is if they intersect at the point of intersection, two tangents can be drawn to the lines of force. That means the intensity of electric field has two directions, but intensity of electric field is a vector and it's impossible. A vector is always have only one direction, so electric lines of force will never intersect. And some more thing I can tell you, it is like the next point is the figures I can show you. If it is a positive charge, the electric lines of force will intersect. Originate like this. Like this you can draw. From the positive charge, the lines of force starts, right? So the arrow will be like this. From the negative charge, it will be like this. It will be going towards the negative charge. So the figure will be like this. In the exam, if they ask, you can draw these figures as well about electric lines of force. If you have two charges closer, you can draw the figure like this. So you have a positive charge. This here you positive charge, excuse me. Here you have a negative charge. The lines of force will start from here and ends in the negative charge. So like this, then like this, here it will reach. So like this. This is the way you can. Oh, one more thing, yeah. So, like this you can draw. So this is the case with a positive and negative charge if they are very close. And if a positive and positive charge is very close, it would be like this. The lines of force can be drawn like this. This is on positive charge, this is on positive charge, then it will be like this. They will repel. See, they will repel. They won't, it will be like this. They will repel. You are getting my point? They will repel like this. They won't meet each other. They will repel. So this is the case with positive and positive, and negative means the arrows will be in the reverse direction. The figure should be the same. So this is all about electric lines of force. So what are electric lines of force? See, electric lines of force are used to represent electric field. Electric lines of force are imaginary concepts, but the field they represent are real. Electric lines of force are imaginary lines drawn in such a way that the tangent to it at any point gives the direction of electric field. Very important. The tangent of electric lines of force gives electric field vector. This is important. Tangent of the line. Tangent of the electric lines of force gives the electric field vector. This is the definition. Electric lines of force are imaginary lines drawn in such a way that the tangent to it at any point gives the direction of electric field. The characteristics of electric lines of force. They start from the positive charge and ends on the negative charge. If the intensity of electric field is higher, the electric lines of force are closer. If the intensity of electric field is smaller, the electric lines of force are widely separated. No two lines of force will intersect, because if they intersect at that point, two tangents can be drawn. That means electric field vector has two directions. It is impossible. So they won't intersect. And another point, you can see these things. For example, if it is a then another point is, what is a uniform electric field? That I have to tell you. I forgot to tell you. That is another point. See, uniform electric field means if the lines of force are parallel. If the lines of force are parallel and equidistant, then the electric field we call it as uniform. This is a uniform electric field. The lines of force are parallel and equidistant. They are equal distance. Then the lines of force are parallel. So if you keep on uniformly charged positive plate and negative plate here, you can get a uniform electric field. If the lines of force are parallel and equidistant, then the field is electric field is uniform. That is another important point you need to remember. Then this is about electric field, electric lines of force. So next thing I am going to discuss here is electric dipole. So what is an electric dipole? Electric dipole, it's an important concept and a derivation essay question, 5 marker or 6 marker question also you can get it in the board exam related to electric dipole. Those derivations we will be covering in the next video. So today I am giving an idea about electric dipole. So what is electric dipole? Two cases are there in the derivation. One is axial position and equatorial position. Electric dipole. See, electric dipole, two equal and opposite charges separated by a very small vector distance. The distance is vector distance. Two equal and opposite charges separated by a very small vector distance denoted by 2a. We use the it as 2a. Very small vector distance, it's known as an electric dipole. Two equal, the charges must be equal. If it is plus q, here if it is plus q, here it should be equal minus q, but it would be minus. Two equal and opposite charges separated by a very small vector distance constitute an electric dipole. I will draw it more clearly. This is plus q, here it would be minus q. The separation is very small. Actually, it is in the order of micrometers, nanometers. I am drawing like this. It's very small. So the distance we take it as 2a. This is a vector distance. The distance is always from negative to positive. So this is known as electric dipole. So what is an electric dipole? Two equal and opposite charges separated by a very small vector distance. The vector distance is known as an electric dipole. In the figure, the charges are plus q and minus q and the distance is 2a. The vector distance is always from negative to positive. Very important. Negative to positive. The vector distance is from negative to positive. This is about electric dipole. So what is an electric dipole? Two equal and opposite charges separated by a very small vector distance constitute an electric dipole. Now I am going to discuss about another important aspect that is known as the dipole moment. See, dipole moment is denoted by the letter P. Dipole moment. Dipole moment is is the product of one of the charges and the vector distance. So it is a vector quantity because the distance is vector but charge is scalar. So this is the formula. One of the charges, the distance we have taken as 2a. So dipole moment is defined as the product of one of the charges. So that's why we have taken only q, and the distance we have taken as 2a. Between plus q and minus q, the distance is 2a. This distance we have taken as 2a. So that's why. So dipole moment is a vector quantity. So when you discuss about a physical quantity, it is a physical quantity, you will learn the formula, definition, its unit, dimension. You will discuss whether it is vector or scalar. I have told you the formula. It is the product of one of the charges and the vector distance, and its formula, it is q into 2a, and I will talk about the unit here. So the unit of dipole moment is coulomb. Charge, it is coulomb, then meter. This is the unit. Then it is a vector quantity, I already told you. Now it's a dimension. Dimension will be, I can write you the dimension for this. So the dimension, it is q. What is the dimension for q? It is a into t, and the distance is l. So you can write it as m raised to 0, l raised to 1, t raised to 1, a raised to 1. This is the dimension for dipole moment. So we covered electric lines of force, what is electric dipole, then what is dipole moment. All these things we covered in this video. So that's all for today. Thanks for watching.